My name is Åke Rosenqvist, and I represent the Committee on Earth Observation Satellites, CEOS, which is a voluntary umbrella organization for national space agencies and satellite data providers. The 62 CEOS member agencies currently operate more than 170 satellite missions, out of which several are of relevance for national forest monitoring and RED+. The focus of this summer presentation is on the first part of the remotely sensed observations chapter in the MGD, and that concerns the spaceborne Earth observation missions that produce the geospatial data recommended for use in this methods and guidance document. While there are also a number of commercial missions in operations today, in particular such operating with very high spatial resolution, the focus here is on the public open missions operated by national space agencies and data providers, from which satellite data are available free of charge in the public domain. The MGD anticipates that medium and fine resolution optical and radar data will be the main types of remotely sensed data used in estimating RED+ activities. Currently, there is most experience with using medium resolution optical data, and this is partly because many countries have been using optical data of this resolution for making national emissions estimates in the past, and because the US Landsat mission provides a historical archive of optical data back to the 1970s that can be used for the establishment of baselines and reference levels. Globally consistent Landsat data exists from around 1999 with the launch of Landsat 7 and its global long-term acquisition plan. Over parts of South America covered by the Brazilian ground stations, there is also a dense archive of medium-resolution optical data from the Brazilian Chinese CEOS missions. Given the successful launch and operations of Landsat 7 and the European Copernicus Sentinel-2A and Sentinel-2B missions, and the long-term plans for their follow-on missions, Landsat 9 and Sentinel-2C and 2D, there is a guaranteed continued availability of optical medium-resolution data for the foreseeable future. Landsat, Sentinel-2 and CEOS are freely available in the public domain. Cloud cover is a known problem that limits the availability of optical data, but with a high temporal revisit frequency of the Landsat and Sentinel-2 workhorse missions, each providing global acquisitions at around a weekly basis, using time series of data can help mitigate problems of interference by cloud cover. Dense time series data can also accommodate the use of these data for near real-time forest monitoring and early warning. So see the new Appendix C in the MGD for more details on early warning systems. Finally, another recent development since the previous MGD release is the move by CEOS agencies towards more user-friendly data formats, commonly known as Analysis-Ready Data, or ARD. Relevant to all types of Earth observation data, optical, radar, LIDAR, data products provided in analysis-ready data formats represent satellite data that have been processed to a minimum set of standardized requirements and organized in a form that allows immediate analysis with a minimum of additional user effort, and also that allows interoperability of ARD's datasets both through time and with datasets from different sensors. See the CEOS ARD homepage for more information about analysis-ready data. Synthetic aperture radar is an active system operating in the microwave domain, which then provides a different and complementary view of the ground compared with optical sensors. Radar signals are well known to penetrate clouds and haze, which enables regular monitoring of areas also in cloud-persistent regions. Longer wavelength radars, like what we call L-band and P-band, also have the capability to penetrate a closed forest canopy and are therefore sensitive to forest structural parameters, and in turn have an indirect, although limited, relationship with above-ground biomass. This makes medium-resolution radar data potentially useful for estimation of activity data, in particular forest removals and forest regrowth. Limited sensitivity to above-ground biomass can furthermore be used to improve estimates of emission factors. Due to its all-weather capability, SAR data are also used for operational near real-time early warning systems in cloud-prone tropical countries, as described in detail in Appendix C of the MGD. Globally consistent historical L-band radar data from the Japanese JRS-1 SAR and ALOS Pulsar missions exist back to the mid-1990s, and these data are available in the public domain free of charge. Key radar missions currently in operations that provide systematic observations of relevance for national forest monitoring include ALOS 2 Pulsar 2, which is an L-band SAR mission. While standard fine resolution Pulsar 2 data are only commercially available, the Japanese Space Agency, JAXA, produce annual 25-meter resolution global Pulsar 2 mosaic products that are available for free in the public domain. The full archive of 50-meter resolution Pulsar 2 ScanSAR data, which are acquired every 42 days over the pantropical zone, are also planned for release free of charge in the public domain by JAXA at the end of the year. A key mission in the shorter wavelength, C-band wavelength category is the European Copernicus Sentinel-1A and 1B constellation, which provides global 10-meter resolution observations every 12 days and over Europe every 6 days. The short C-band wavelength is complementary to L-band in sparse and open forest areas and is sensitive to low biomass vegetation, such as early regrowth, bushes and shrubs, where the longer wavelength display limited sensitivity. Sustained availability of public radar data is secured well into the next decade, with a suite of new missions scheduled for launch throughout the 2020s. This includes the European Biomass Earth Explorer mission, which will be the first spaceborne P-band SAR mission. With a wavelength almost 3 times longer than L-band, backscatter sensitivity with above-ground biomass increases significantly. With a planned launch in 2022, Biomass will, during its 5-year mission life, produce near-global maps of above-ground biomass and forest height at 200-meter spatial resolution every 7 months. All biomass data and products will be provided by the European Space Agency ESA free of charge in the public domain. As the concept of radar and microwaves is different from that of traditional optics, some basic understanding of SAR technology and how radar signals interact with different land cover types is recommended to properly understand and utilize SAR data. The MGD update therefore provides a brief summary of some key SAR features and radar terms. The MGD also provides links to public open SAR guidance and training materials. CEOS has published a simple guidance document called A Layman's Interpretation Guide to L and C-band SAR data to help users with little or no experience of SAR data to get started. For more in-depth background to SAR theory and forestry applications and tutorials, the SAR Handbook, Comprehensive Methodologies for Forest Monitoring and Biomass Estimation, published by Silva Carbon and Servier Global, is recommended. LIDAR is an active remote sensing technology, the optical version of radar, which uses pulses of laser light to interact with different strata of the vegetation and from which quantitative information on vegetation vertical structure can be estimated. As LIDAR systems provide direct measurements of ground and vegetation height, they are highly relevant for the estimation of emission factors. Since 2018, we have 2 spaceborne LIDAR missions in operations, both operated by NASA. ISAT-2 and the Global Ecosystems Dynamics Investigation Mission, JEDI, which is mounted on the International Space Station. The spaceborne LIDAR systems provide point measurements along the spacecraft ground track, and they are therefore often used in combination with optical or SAR satellite data to interpolate estimates between the LIDAR sample points. ISAT-2 is a so-called photon count LIDAR, from which estimates of terrain height, canopy height, and canopy cover can be made. GFOI is a so-called full waveform LIDAR, which in addition to ground and vegetation height also measures the amount of laser energy reflected by stems, branches and leaves at different heights above the ground. The waveforms are processed to provide metrics for each footprint, such as terrain elevation, canopy height, relative height metrics, and leaf area index. All ISAT-2 and GFOI data and products are available for free public download. This also includes historical ISAT-2 glass data collected between 2003 and 2009. The future availability of spaceborne LiDAR is a bit shaky though. ISAT-2 has a nominal mission life of 3 years, with a possible extended operation depending on instrument performance. GFOI has a nominal mission life of 2 years. A potential savior is the multi-footprint observation LiDAR and imager mission, MOLI, which is a spaceborne LiDAR mission under consideration by JAXA for deployment on the International Space Station around 2024. MOLI is a full waveform LiDAR that potentially could provide important continuity to the GFOI mission. Finally, to summarize some of the key points in the update. A large number of key new generation spaceborne missions have been launched or have become fully operational since the previous MGD release. The new generation missions provide global scale, medium resolution coverage at high temporal revisit frequency. The missions comprise complementary sensor types, optical, radar at different wavelength bands, and LIDAR, that are useful to address various aspects for making natural emissions estimates. An important point is that the data from the key missions are publicly open, available free of charge for users. Another important point is that the data supplies from the key optical and SAR sensor types are well secured into the 2030s. And finally, the concept of analysis-ready data is being adopted by many data providers in an effort to make Earth observation data easier for the users to access and utilize. Thank you very much for your attention.